Welcome back to Quantitative Reasoning. In the previous tutorial, we explored the 4 different panes of the RStudio window. We also learned how to assign a single number to a variable using the assignment operator, composed of a left angle bracket and a hyphen. In this video, we learn more about assigning values to variables. More precisely, we learn how to create an R data structure called a vector. Consider this example. 5 players roll dice, and we want to save the results. We could store each individual result in 5 different variables, but this would be cumbersome. Instead, we want to create a single variable called scores that contains all 5 results. The command we use is scores gets c, where the function c combines the numbers that we're going to type between the parentheses. Suppose the players rolled 5, 6, 1, 6, and 3. It doesn't matter whether we leave a space after the comma. R understands what we mean with or without the space, but separating the numbers with commas is important. As we learned last time, we run this command by moving the cursor to the corresponding line. Then we click Run. Now the variable scores is in the environment. In the R jargon, an object that can contain multiple elements, such as our variable scores, is called a vector. The abbreviation NUM in the Environment tab tells us that scores is a vector whose elements are numbers. We encounter vectors with other types of elements later in this tutorial. The symbol 1:5 in square brackets tells us that scores contains 5 elements that are indexed with the integers 1 through 5. We now learn how to access individual elements in scores. Because it isn't important to save the next few commands, I'm going to type them into the console. But please remember that when we want to save commands, we should type them in the editor and run the commands from there. In tutorial 4, we learn how to save the commands in the editor. We access elements in a vector with square brackets. For example, we can view the third element in scores by typing scores in square brackets 3. The output is 1, which is indeed the value of the third element. We can also perform operations on individual elements. For example, scores in square brackets 3 plus scores in square brackets 5 adds the third and fifth element. 1 plus 3 equals 4. We can perform operations not only on individual elements, but also on entire vectors. For example, let us define another vector. X gets c, 2, 6, 3, 2, 3. When we type scores plus x, the output is 7, 12, 4, 8, and 6. Can you spot the pattern? The first element in the output is the sum of the first element in the 2 input vectors scores and x, namely 5 plus 2. The second element in the output is the sum of the second elements in scores and x, namely 6 plus 6, and so on. How about scores minus x? We could explicitly type score minus x in the console, but let me show you a trick that can sometimes save you time. Press the up arrow key once. Then we are back at the previous command we ran in the console. In general, we can go back and forth through previous commands by using the up and down arrows. Let's go back to the previous command, scores plus x, and replace the plus by a minus sign. The result of scores minus x is the element-wise subtraction of x from scores. That is, the first element of the output is the first element of scores minus the first element of x, and so on. The same element-wise arithmetic happens when we multiply. The first element in scores times x is the first element of scores multiplied with the first element of x, and so on. Please note that the multiplication symbol in R is an asterisk. Other important element-wise arithmetic operations are division, whose symbol is a /, and exponentiation, whose symbol is a caret. Okay, we now know how to perform arithmetic with 2 different vectors, but occasionally we may want to sum all elements in one vector rather than adding elements in 2 vectors. For this purpose, R provides the sum function. Sometimes we want to store non-numeric objects in a vector. For example, we may want to save the names of the 5 players who rolled dice. Again, we use the c function. If we want to call the vector players, the command is players gets c, where we are going to write the players' names between the parentheses. Suppose the players are called Rachel, Tatiana, Noah, Quentin, and Aisha. We type the names in quotation marks and separate them by commas. The quotation marks are important, otherwise R doesn't understand what we mean. Run this command and we'll find the variable players in the environment. When we compare players with scores, we can see that they are of a different class. Instead of NUM, we see CHR in the Environment tab. While NUM stands for numeric, CHR stands for character. We can access character vectors in the same way as numeric vectors. For example, players in square brackets 2 returns Tatiana. Be careful when mixing numbers and characters in one and the same vector. R converts the numbers to characters, and the result may not be what we intend. For example, use the up arrow to go back to the command with which we defined x. Now add one more element to it, say Rachel in quotes. We can see in the Environment tab that x is no longer numeric, NUM, but a character vector, CHR. In particular, the numbers 2, 6, 3, 2, and 3 are now all surrounded by quotation marks. This output shows that 2 is no longer the number 2, but the character 2, just as, for example, Rachel is composed of characters. As a consequence, arithmetic operations such as x in square brackets 1 plus x in square brackets 2 no longer make sense. We cannot add words in the same way in which we can add numbers. This fact is exactly what R points out in the error message, non-numeric argument to binary operator. Here the binary operator is the plus. You might be wondering how we can combine numeric and character data. For example, wouldn't it make sense to have an object that lists the players' names together with their scores? Something that resembles an Excel spreadsheet with names and scores in separate columns. We learn next time how R handles such spreadsheet-like data with objects called data frames. But right now, let's summarize what we learned in this tutorial. We learned how to create vectors with the C function. Vectors can be numeric or contain characters, but we cannot mix numbers and characters in the same vector. We can access elements in a vector with a square bracket notation. If the vector is numeric, we can perform element-wise arithmetic, plus, minus, multiplication, division, and exponentiation. The sum function returns the sum of all elements in a numeric vector. In the next tutorial, we learn how to combine multiple vectors into a data frame. See you soon.